Hey guys, we're here for the second video, integumentary system. This in a lot of ways feels like the first concept of the integumentary system because we're finally getting into talking about the different layers of your skin, the different glands that are inside, and how those glands help you regulate temperature. Next time we'll talk more about the different cell types, and I love the next lecture actually a lot on keratin. Keratin's a really cool substance we'll learn about. We'll start learning about different layers. We'll learn about different functions. Start learning about there's a big table of functions in your textbook on the integumentary system that's really important. We'll start dipping into that today. So let's roll. Quick review, so I can hit this several times. Let's review the last question. Is your skin a tissue or an organ? See if you can think about how you'd answer that. So go ahead and pause the video. We talked a lot about last time about how your skin really is an organ because there are multiple tissues. So there's the epidermis, the dermis, and the hypodermis. Basically stratified squamous, dense connective tissue, and adipose tissue, fat tissue. So yeah, it's an organ. But it also joins other organs like your hair, nails, exocrine glands, and it joins those. Actually, I changed this one. There we go. So that's what it should say. I changed that one. I cut those out because those blood vessels and nerves are part of a different organ system, but these ones are inextricably linked to your integumentary system since they perform the same function and have no other organ system. So again, your membranes are organs. Your skin is an organ because it's made of multiple tissues. Your skin joins with other organs to create the integumentary organ system. So that's kind of how that works. Okay, so first concept, guys, is once you jump into your skin, this is the entire model of the skin. I have that kind of cheesy older model in class. I like this one quite a bit. If I zoom into this top layer, this epidermis, there are many layers within. Ignore these cell types for now, these Merkel cells, keratinocytes, melanocytes. We're going to talk about the layers for now, and we'll get into the cells and cell function tomorrow. From the very, very top is all these dead cells. So when I look at you, or you look at me, my face right now, as ugly as it is, the reason why I'm so ugly is that all you're seeing is dead cells. All you see really is stratum corneum. All sorts of cells that used to be alive down here that have on their deathbed here in the stratum granulosum, and they're fully dead up here in the stratum corneum. And so that's what you look at when you see me, and I'm really sorry about that. So stratum corneum, deeper is the stratum granulosum, deeper to that is the spinosum, deeper is the basale. That's the base layer. And then you get into that next layer, the dermis, this section in here. There's a way to remember this. There's actually another possible layer also. There's the stratum lucidum. Stratum lucidum is a layer, if I zoom forward, stratum lucidum, if you guys see this, is this clear layer, and that's found in really, really thick skin in the palms of your hands, soles of your feet. So that's a fifth layer of your epidermis only found there. So can girls sing bass? I think of the Meghan Trainor song. Can girls sing bass is what you typically find. Can, corneum, girls, granulosum, S, spinosum, B, basal or basale layer. And then the last one was the lucidum, stratum lucidum, is the L. And that's kind of a funny acronym with the large thrown in there. But again, thinking of the Meghan Trainor song, that's one way to remember it. So can large girls sing bass? That's the epidermis from the most superficial layer to the deepest layer. If you turn in your yellow packet, there's actually this zoomed in picture. Feel free and label that right now. That's actually a great way to apply this. There's a bunch of stuff we're going to label in here. But right now, that's the first step, is to label all of these layers in your epidermis. Feel free and do that. Go ahead and quiz yourself on this real quick. Pause the video and quiz yourself. So this is the can girls sing bass, and this is your dermis down here. So stratum corneum, stratum granulosum, stratum spinosum, stratum basale, and then your dermis down here. So those are the 1, 2, 3, 4 layers of your epidermis, and then a fifth, kind of another huge different layer, different tissue, dermis. Okay, so going into your dermis now, we're past these layers of your epidermis right here. Now we're going into your much more expansive dermis. There's two different layers, two main components of your dermis. There's the papillary layer up top, there's the reticular layer on bottom, and let's get into both of those. So your papillary layer up top is made of these dermal papilla, which are projections. You guys see these big hills and mountains. These dermal projections, these dermal papilla, are actually what cause fingerprints to come up like they are. And we'll talk this next class about identical twins and if they actually have identical fingerprints and why or why not. So dermal papilla cause fingerprints, cause these rolling hills in the dermis, cause slightly less rolling hills in your epidermis, and those are the ridges we know as fingerprints. There are also capillary loops. These dark folds, these dark capillary loops, is where blood flow. So arteries are going away from your heart, veins are going back towards your heart, all the same road, and they marry in these capillary beds where the blood, oxygen, and CO2 can pass back and forth to tissues. So capillary beds is really where all of the action happens. I'm going to use this analogy a lot. I go to Salem to visit my in-laws. I love my in-laws. I go on I-5 down this massive artery called I-5. Then I go to these arterioles, which are like a highway or a large street in a city. And eventually I go to the side street where I actually get out of my car and go into my in-laws' house. And that's like the capillary bed. That's where blood actually is transporting oxygen and CO2, gas exchange actually happens in the capillary beds. So you have blood running all throughout your papillary layer. That's really the most superficial location of the blood. So if you damage your skin, you're bleeding everywhere, you are tearing through your epidermis and getting to those capillary beds of your papillary layer. Also in the papillary layer, you have a couple types of receptors. You have pain receptors. Let me see if you can't actually see pain receptors too well in this diagram, but there's pain receptors going up into the dermis here. Pain receptors are there, and touch receptors. So touch receptors is when I barely touch my finger, I can sense it. I'm pushing hard enough to go past my epidermis. My dermis is jostled, and that stimulation goes in my brain. It says my finger's being touched, which is different than in your reticular layer. So deeper in your dermis is your reticular layer. Let me start from the middle here. You actually have pressure receptors. So rather than my papillary layer, which is touch, if I push down, that's actually a different receptor type. And that's in my reticular layer. That's a pressure receptor. So this is the deepest layer of the skin. I might disagree with that. I think the hypodermis is kind of another layer of the skin too, but it's getting deeper. These are where all of the sweat and oil glands are for the most part. You have much larger blood vessels. This is where this big protein called collagen is. This is what gives your skin the rigidity that it has. So when you get old and you have flabby skin, or you're out in the sun and you have damaged skin from the sun that eventually becomes really flabby and wrinkly when you're older, it's because of the breakdown of collagen in this reticular layer. We'll have an article to read on that in class. And lastly, you have phagocytes. Phago means death. So you have these phagocytes, which is kind of like a white blood cell that kills bacteria in this reticular layer. So bacterial protection is in your dermis primarily. And if I zoom this out so you guys can see it, this is the really super helpful, super important table of functions of your integumentary system. We'll have a big essay on this on the next summative. So let's see ones we talked about already. We talked about bacterial damage. There is some prevention of allowing bacteria in your epidermis, but a lot of those phagocytes reside in that reticular layer of your dermis. So check, bacterial damage is prevented by your integumentary system. So those phagocytes in the reticular layer of your dermis are really what ingest and prevent bacterial damage deeper down. So that's a big one. So check, that's the first one we talked about. Okay, so moving on. So quick review, guys. Can you name the layers of the epidermis and the two layers of the dermis? Go for it. And say what tissue type they are. So pause the video. And once you do that, we've talked about the epidermis, the dermis. We've talked previously about this being stratified squamous tissue. Talked about this being dense connective tissue. You have can large girls sing bass in the thickest layers of your skin. You have the papillary layer and the reticular layer. I remember that by saying PR. This is your papillary layer and your reticular layer. PR is like a personal record in track. I was a track athlete, so what's your PR? You'd ask someone. So that's the way I remember that order, PR. In your yellow packet, you have a coloring page that has to do with these layers. Has a little bit to do with like melanocytes that we haven't talked about yet. But there's some hits here, and you can even see the answer key on the previous page. So you could do what we've talked about already on that page. Okay, quick break before we talk about glands. This is one of the last really good pictures my son had with my dad before my dad passed away. I remember my dad. My dad was a pretty frugal guy, didn't buy us much. My mom was born with a silver spoon in her mouth. She likes to spend money. My dad didn't at all. I remember this time. This is a Thanksgiving festival, harvest festival, and my dad paid for us to ride on this big tractor out, which is like 100 yards away. We could have just walked. I remember my dad paying a lot of money for us to ride on this tractor because my son would enjoy it. It's funny how much my dad changed as a grandfather. I love my dad. I missed my dad. That was my son when he was, I think, 4. Okay, so we are talking now about glands. It might seem weird that glands are in your integumentary system, but it's not that weird because your endocrine system is not your exocrine glands. Your endocrine glands are different than exocrine. So we'll talk about the meanings of these words. So you guys can see some glands here. There's some glands here, and there's a gland here. We'll talk about all 3 types of these glands. You'll notice that they all pump stuff to the outside of the body directly to the outside, and that's important. So here's some X-ray, X-rays of an eccrine gland, of a sebaceous gland. So I hope by the end of this unit, we're really ending here in heat regulation. You guys will know what apocrine and eccrine and sebaceous glands do. So real quick, before I get into what glands are, I want you guys to think about endocrine and exocrine. You might have heard in the past about we've developed technology that you might give a human exoskeleton, someone who is handicapped will have this exoskeleton that would provide the power for them to move around independently without a wheelchair. Beetles also have exoskeletons, lots of insects have exoskeletons. So exoskeleton, exo means outside, endo means either under or inside. So you have an inside skeleton, you have an endoskeleton, as opposed to this exoskeleton. So when we talk about glands, exocrine glands, endocrine glands, this must mean glands that produce stuff and release them to the inside of your body versus glands that produce stuff and release them to the outside of your body. So the exocrine have ducts to the outside, endocrine are ductless, they don't have ducts to the outside of the body. A sebaceous gland releases oil to the outside. So everything we've talked about so far has been endocrine. You have hormones that are released from glands into your bloodstream. You maintain homeostasis by maintaining different levels of chemicals in your bloodstream. But now we're talking about exocrine glands, and so those can be part of the integumentary system. Those are not a part of the endocrine system. Are all cutaneous glands exocrine? Using the analogy earlier, yes, they are. This one is exocrine because it goes outside, has a duct to the outside. This one releases into a hair follicle and releases outside. So yes, all 3 gland types that we're going to talk about in a second are exocrine because they release to the outside. Okay, so first type we're going to talk about is sebaceous. Sebaceous glands are just oil glands, oil secreting glands. They have ducts that open into hair follicles. You have them all over your body except for 2 places, in the palms of your hands and the soles of your feet. So in the areas that you have the stratum lucidum layer of your epidermis, you do not have sebaceous glands. What do they produce? They produce a thing called sebum, and sebum releases oil. So what we usually call oil is fat. So glycolipid, you might think of this as a carbohydrate, like glycogen, and a lipid, a fat. So sebum is the thing that sebaceous glands release. Inside the sebum, there are these carbohydrate fats and a host of other chemicals as well. So a function of sebum, one function is to lubricate, to keep skin soft and moist. So oil is useful for preventing desiccation or drying out. Desiccation, 1S, 2Cs. It prevents hair from becoming brittle, so sebum's great for oiling up hair and keeping it moist. And those chemicals, those host of other chemicals, are incredibly effective at killing bacteria. So you guys just remember the reticular layer of your dermis has phagocytes to kill bacteria, and on the outside you have this sebum. which can kill bacteria. So check, that's another way that your integumentary system prevents bacterial damage and why a really bad burn sucks. So again, bacterial damage is here. We've talked about this acid mantle. There's these skin secretions called sebum that are acidic. They actually kill bacteria. The bacteria die in the acid, in those chemicals. And the phagocytes deeper in the dermis prevent it. So check. Interestingly, what is a blackhead, a whitehead, and acne? And they all have something to do with a sebaceous gland. So imagine with me, guys, that you have this hair follicle coming out, and that duct, which is also the exit point for sebum from your sebaceous gland, is blocked. So you have this big buildup of sebum, of oil. So that is generally thought of as a whitehead. A blackhead is when the very, very tip gets oxidized, which turns black. And again, you can squeeze your nose and squeeze out blackheads. That very tip is the edge in which oxygen converts that sebum and turns it black, oxidizes it. Acne, what we would actually call acne, which is more of a severe condition, is saying you actually have a bacterial infection in those blocked hair follicles. Those sebaceous glands can't get their pus out, and there's a bacterial infection making it worse, which can spread across the skin. So P. acnes is the species of bacteria. So when you say I have acne, you're saying I have an infection of P. acnes, the species of bacteria that infects sebaceous glands. I think that's pretty cool. Kind of gross, but pretty cool too. Before we move on to another kind of gland, this is my, I think the last picture I have with my dad before he passed away. I was graduating teaching school, so this is back in 2011, 2012. And my dad, I think, passed away a couple weeks later, 2 or 3 weeks later. And we'll talk about, hopefully we'll have a day where we'll talk about cancer and why my dad's pancreas right here, why having a pancreas cell that cannot stop dividing is a problem for his vision. But again, my dad was a big dude. He was like 350 pounds for most of his adult life. And he was down to about 195 here at the end of his life. Okay, so we just talked about sebaceous glands, which is one type, and the other main type is sudiferous glands. A sudiferous gland is just a sweat gland. So if you want to sound really, really smart, you can say that you have profusive sudiferous glands, overactive sweat glands. So there you go. Tell one of your family members that, and they'll be like, what are you saying? Each person has an average of about 2.5 million sudiferous glands. Those who are larger will have more. But these are incredibly common all over the body. Of the sweat glands, there are 2 types of sudiferous glands. There's eccrine and apocrine. I would actually practice saying that. Eccrine, apocrine. Eccrine are found everywhere. They are found all over your body, including the palms of your hands, soles of your feet. Interesting question would be those people who sweat out of their hands. There's actually Mr. Bauer had a student who sweat profusely out of their hands 2 years ago. Why would that be? What's different about their eccrine glands? Those ducts open into tiny pores, not necessarily in hair, even though this looks like it's open into hair. And this produces sweat to regulate body temperature. So that's the main function of sweat, is to help you regulate body temp. We'll talk about that in a second. The other type, apocrine, is found in 2 particular areas, basically the smelly areas. So this is in the axillary or armpit area or the genital region of your body. These open onto hair follicles and they secrete. Their secretions are not called sweat, and they are only marginally helpful with body temperature. So let's talk about these 2. So apocrine, again, found in the axillary region, the armpit region. Their secretions are basically twofold. They secrete fatty acids, so in your armpits and genital region, when you are, those glands are excreting out their products. It includes fat and protein. It's odorless, so your sweat glands, your apocrine glands in your armpit and genital regions don't smell. But what does smell is when the bacteria eat them. So as the bacteria eat those fatty acids and proteins that your glands are producing, they get metabolized, and the byproduct is that stench. And that's usually what we call body odor. So body odor is to say, oh, I love this person's body odor, which is a weird thing to say, but married couples oftentimes actually say that. You get used to it, at least. It's almost like nostalgic. It's a result of the bacterial fauna, the bacterial species in the genital and axillary regions that are eating the fats and proteins produced by your apocrine glands. Again, this is weird stuff. Even if you're not going to medicine, I think that's really weird. I think really cool to know about yourself. When are apocrine glands active? They are active most often during stress, sex, pain, but their function is kind of unclear because it's marginally helpful with regulating body temperature. Is the function of it to actually have the bacteria metabolize and produce this odor, and the odor itself is the function? That's an excellent question. Not totally sure. I spent a while last year researching that. Not clear what the function is. Okay, guys. So just quick review again. We talked about sebaceous glands over here. That's the oil gland producing sebum. Now we're talking about the sudiferous glands, sweat glands, and there's apocrine and eccrine. And eccrine are the type that produce that are everywhere in your body. They're the ones that we usually think of when we think of sweat glands. In sweat, the composition of sweat is made of a bunch of different things. Water being the main one. I bolded that here. But also salt, vitamin C, urea, uric acid, ammonia, lactic acid, lots of different things in sweat. Sweat is also fairly acidic, which inhibits bacteria. And we've talked about that acid mantle. It's an acid barrier of your integumentary system. And it plays a huge role in heat regulation. So nerve endings stimulate eccrine glands when temp is too high. They are thermoreceptors. Thermoreceptors sense the thermometer, sense the temperature in your skin. When the heat is too high, then they activate the eccrine glands, which will produce sweat. When water evaporates off your skin, this is actually really cool. When the water molecule heats up and evaporates off your skin, it actually pulls a lot of heat with it. So the evaporation of sweat is incredibly important for heat to radiate out, get pulled out of your body and evaporate off, which is why it feels really nice to have a fan and pour water over yourself when you're super hot so that you can encourage the evaporation of water, encourage the radiation of heat out of your body. So real quick on that, real quick review of heat regulation. We've done this one before in class, but those thermoreceptors in your skin are sensed in your skin that reports it back to the hypothalamus, either too high or too low. And then you have these you have these effectors, you have these responses to bring the temperature back down or back up, whether that would be dilation or constriction of blood vessels, whether that would be the activation of eccrine glands or the activation of muscles to shiver. And this is how this beautiful fine balance of body temperature is maintained. So last thing, we're almost done. I know it's almost 25 minutes. So two questions come up is what happens when heat regulation goes haywire? And a really weird question is why when it's hot outside, like 100 degrees, why do we sweat? Because that's like the same temperature as our blood. Isn't that weird? Our blood is like 98 degrees. Why are we sweating profusely when it's 98 degrees outside? It's a weird thing. Let's answer those two briefly. Hypothermia, hyperthermia. Hypothermia is what we usually use to describe frostbite when those blood vessels constrict and they prevent blood from getting to my fingertips. My hand or my fingertips turn purple. There's lack of blood flow there, and when I don't have blood flow transporting CO2 out, oxygen in, waste out, nutrients in like glucose, then those tissues start to die, and so I start to lose those fingers. And they start to turn black, they start to die and become necrotic. So it's hypothermia, frostbite. Hypo meaning less, hypo means less, hyper means more, like the hyper kid at the store with energy. So hyperthermia, which would be something like heat stroke or heat exhaustion. So hypo, hyper, those prefixes are super important, so write that down somewhere. Last question is why do we sweat when the outside temp is 98 degrees and our inside blood temp is 98 degrees? And I find that really, really weird. And I don't think I'm going to answer that question on the video. How about we do that in class? See you guys in class.